Okay, in this topic, what we are being asked is to transform the graph of this function. So the exercise is giving us a function, a rational function, and its graph, and is asking us to use the knowledge we have so far of how parameters affect our graph and use that knowledge to transform, that is, to move our function around and to transform it accordingly. So let's start. To do that, we need to remember this. What if I give you the general form for this function? Remember, any general form function, any general form for a function is going to look like this: a leading coefficient multiplying the function, where the argument can have a number either adding or subtracting, and then I'm going to have an independent term. So if I write the function like this, things are starting to look familiar. So let's dig a little bit deeper. Notice that here I have the vertical and horizontal asymptotes drawn. So here's my horizontal asymptote and my vertical asymptote. Notice that these asymptotes cross each other in a point. What point is that? Is a point 0, 0. And we can call this the center of the graph. This is a nickname we're going to use for purposes of understanding and associating what we know so far with this type of exercises. So the center or vertex, even though it's not a vertex, of this function is 0, 0. Now, we know that if we have a number adding or subtracting to the x coordinate, that is going to affect the x. If we have a number adding or subtracting to the x variable, that is a number adding or subtracting in the argument, that is going to affect my x coordinate. And an independent term adding or subtracting at the very end affects our y coordinate for the vertex. So, and remember that the leading coefficient affects the rise. So finally, we have the center of the function and we need to find the pattern of the function. So to identify the pattern of this function, we have to know for what values of x, or for any value in x, how much is my function in y. To do that, we will always start to run or rise from the vertex, okay? So starting from the vertex, what happens with the original graph if I run 1 to this side? Notice that if I run 1 to the right, it's the same as evaluating the function in 1. So the evaluating the function in 1 is going to give me 1. That is, if I run 1 to the right, I'm going to rise 1 upwards. So what happens here if I have a number multiplying my function? Remember, this is called the leading coefficient, and the leading coefficient affects our rise, meaning that if this function in its original way, if it runs 1 to the right, starting from the vertex, it rises 1, the A is going to affect this rising, meaning that if I run 1, I'm going to rise 1 times 2, because in this example, the leading coefficient is 2. So 1 times 2, that is 2. So let's go ahead and affect or apply this transformation. To do that, we're going to use this tool. So this tool, what does it do? It identifies the first run-rise point, and we're going to modify it. Starting from the vertex here, you know that if you run 1 to the right, the original pattern was to move 1 upwards. But if you multiply your rise times that leading coefficient, you're going to be rising 2 instead. So if you run 1 to the right, you're going to rise 1, 2 up. So if you move 1 to the right, you're going to rise 1, 2. So we have applied the first transformation. The next transformation is associated with the vertex of this function. Remember, these asymptotes cross each other in the point 0, 0. This transformation has no effect or no number adding or multiplying the x variable. So this means that the vertex transform has an x coordinate of 0. And because I have an independent term of -4, that means that my y coordinate for the new vertex is going to be 0, 4. So that means I have to move everything to this new vertex. So this vertex is going to be moved to the point 0, 4, 0, 4. And that's it. We have applied the leading coefficient transformation and the moving vertex transformation, and that's it. Another example. Here I have this function. Again, what? Continue. Here I have another function. So let's start identifying things. The leading coefficient for this transformation is -1. So this means that my function, instead of, remember that the leading coefficient tells us where this function opens, if it opens upwards or downwards. So my original function looks like this. The leading coefficient being negative, it means that if a function opens upwards, it's going to open instead downwards. What does this mean? If this is our original function and it moves upwards here and downwards here, multiplying it by 1 means now I'm going to be open from this part of the graph is going to flip back downwards, and this side of the graph is going to flip upwards. What does that mean? I'm going to apply this property. This property flips everything backwards. So notice, what is upwards is going to be downwards, and what is downwards is going to be upwards. Why? Because the negative sign means that everything that went upwards is going to go downwards. So flipping the function. That's the first transformation. Now let's move the function to its new vertex. Notice that the argument of the function, that is x minus 1, is being affected by a -1. So as always, we are going to write x equals 0, and that means x equals 1 is the new coordinate for my new vertex. And because I do not have an independent term being added, that means that my y coordinate for the vertex is 0. So I'm going to move this entire function using the translation property into 1, 0. And that's it. We have applied the leading coefficient transformation and the moving the vertex transformation. One last example. In this case, notice that we have a transformation in the vertex of my function, and I have a leading coefficient multiplying the original graph. So let's start by applying the leading coefficient transformation. Remember, the leading coefficient transformation affects the rise. So if this is my vertex, let's identify first the pattern of the original function. In this pattern, if I move 1 to the right, how many do I have to move upwards for me to touch the function? Notice that if I move 1 to the right, I have to rise up 1 for me to touch my graph. The leading coefficient is going to affect the rise, meaning that if I move 1 to the right, I'm going to have to be moving 1, 2, 3 upwards, meaning that I have to move this point of the graph to this point. To do that, I'm going to use this property. This property changes the point to this place. Notice that this point is a result of moving 1 to the right and then moving 1, 2, 3 upwards, always starting from the vertex or the intersection of the asymptotes. Once we have done that, we can go into moving this entire graph to its new vertex. Notice again, the transformation to the argument is given by this expression. So if I solve for x, this is x equals -1. That is the x coordinate for my new vertex. Because I do not have a new number adding or subtracting outside my rational function, this means that the y coordinate for my vertex is 0 because I have nothing being added or subtracting. So the new vertex of center of my graph is going to be -1, 0. So I have to move my entire graph to -1, -1, 0. Here's the new center. I have applied both transformations, and that's it.